Hi guys. For this video we're going to be taking a look at something which is probably going to be pretty familiar to you. You probably learned about it, I'm guessing, back in middle school. But if not, it shouldn't be that hard to learn, even if you've never heard of it before. And of course I'm talking about the Pythagorean theorem. It's one of the most well-known formulas in all of math. And here's what it says. Technically in your book it's called Theorem 8-2, but we're going to be referring to it, of course, as the Pythagorean theorem. It says that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So if we're looking at this picture right here, triangle ABC with a right triangle is a right triangle, and it has a hypotenuse over here that has a length of C, and the legs have lengths of A and B, then according to the Pythagorean theorem, the square of the hypotenuse, so C squared, is equal to the sum of the squares of the legs, so A squared plus B squared. We usually hear it referred to as A squared plus B squared equals C squared, just kind of flipping around the two sides of the equation right here. Either way is fine. I usually, when I write it and when I talk about it, I say A squared plus B squared equals C squared. So that's it. Let's see how it works out in some problems. Down here we have four right triangles, and our job is going to be to try and find the value of each variable in the diagrams. And you'll notice that they're all right triangles, and we're looking at the side length, so the Pythagorean theorem definitely applies here. So for example A, I'm going to start off, I always start off by writing A squared plus B squared equals C squared. Now, of course, I don't have A's, B's, and C's here. I have a 5, a 10, and an X. So the first thing I need to do is I need to kind of maybe either mentally or literally on my notes or on the sketch that I've made on my homework, I need to relabel these sides as A, B, and C. And really the only one that matters, the only one that has to be one of these specific letters is the hypotenuse. The side that's across from the right angle always has to be my C. So I'm going to put a little C in parentheses next to the X in that case. These other two sides are, of course, the legs. It doesn't matter which one's A and which one's B. You don't have to have the short one be A and the long one be B or anything like that. It's personal preference. So I'll put an A right here and I'll put a B right there. So now I know that these are my A's and B's and this is going to be my C. So what I do is I fill in the numbers, or in this case the variables that I have for my A, B, and C, and then I work through and I solve it. So for A squared, I'm going to put 5 squared. For B squared, I'll put 10 squared. And for C squared, I'll put X squared. Now I want to try and figure out what X has to be equal to. So the first thing to do is simplify these things. 5 squared, it's not 5 times 2, remember, it's 5 times 5. So that'll be a 25. 10 squared is 10 times 10, so that'll be 100. And then I have an X squared over here. I can combine these two like terms and get 125 equals X squared. And now, of course, we know that what this means is I need to do the square root of both sides. So X, I'll flip this around a little bit, X is going to be equal to the square root of 125. Now 125 is 5 times 25, and 25 is 5 times 5. So this means that X is the square root of 5 times 5 times 5. So these two 5's will circle, and we'll tell them to come outside the radical. So X is going to be equal to 5 times the square root of the thing that's left, which is a 5. So 5 root 5 is our answer for X in this diagram right here. Now part B is a little bit trickier. We can see we have a side here labeled y minus 1 and a side here labeled y, and then we have a side of 5. So we're going to use the Pythagorean theorem, and this is my C because it's across from the right angle. That means that this can be my A and this can be my B, or vice versa. It's really up to you. So when we start filling in our values for A, B, and C in the Pythagorean theorem, we have to remember that this whole thing is going to get squared. That whole thing is 1, so the whole quantity right here, y minus 1, gets squared. Then of course we have a 5 squared for my b squared, and we're going to have a y squared for my c squared. Now this is where a lot of people are going to make a mistake. They're going to think that they can distribute this squared in here and just make it y squared minus 1 squared. You need to remember you can't do that. This quantity being squared means that the quantity y minus 1 is going to multiply times the quantity y minus 1. We're going to have a plus 25 here equals y squared. Now when you multiply these two binomials together, we have to use that FOIL method that you learned back in Algebra 1. We have to take y times y times negative 1 times y, oops, this should have been a negative y. Negative 1 times y is negative y, and negative 1 times negative 1 is going to be a positive 1. So this is what we end up with there. Y squared minus y plus 1. Then we have plus 25 equals y squared. Now we'll clean this side of this equation up by combining like terms, and we get y squared minus 2y plus 26, combining the 1 and the 25, equals y squared. Now the next thing we want to do is try and get all our variables over onto one side. And since there's this one variable expression on the right side of my equation, I'm going to move him over to the other side. So I'll say minus y squared minus y squared. Now what happens is these y squareds cancel out, and I'm left with negative 2y plus 26 equals what? There's nothing over there. So what do we put? We put a 0. Next, we want to try and now get this y term by itself. So we're going to subtract 26 from both sides. Negative 2y equals negative 26. Divide both sides by negative 2, and we get y equals positive 13. And so that's our value of y in this equation. It took a little bit in this diagram. The value of y is 13. It took a little bit for us to get there, but it's the Pythagorean theorem. We just had to be careful about squaring this binomial right here. In example C, we have something that looks a little bit less complicated. So let's go ahead and work this one out. A squared plus b squared equals c squared. Of course, across from my right angle is going to be my c. I'll call that one a, and I'll call that one b. So I'm going to have y squared plus 4 squared equals 6 squared. So y squared plus 16 equals 36. Subtract 16 from both sides, and I get y squared equals 20. Now I know that I need to do the square root of 20 to get my y. I need to simplify this because it's not a perfect square, and I need to check and see if there are any perfect square factors or if I can break that down. And so the square root of 20 is 2 times 2 times 5, the square root of 2 times 2 times 5. And you'll notice I have a pair of 2's right there that will come outside my square root. So y is going to be equal to 2 times the square root of 5. And there's my value of y for this diagram. Now lastly, we have this one, which has 2 x's. Now we can solve this because even though there's 2 x's, that's not 2 unknowns because it's the same unknown in both places. And we have a 4 right here. Now we know that that's going to be our c, and one of these can be our a, and the other one can be our b. So a squared plus b squared equals c squared will look like x squared plus x squared equals 4 squared. Combine these two like terms, and we have 2x squared equals 16. Divide both sides by 2, and we get x squared equals 8. So x is equal to the square root of 8. And the square root of 8 is the square root of 2 times 2 times 2. So these two 2's will come outside as a single 2, and our value of x will be 2 times the square root of 2. So x equals 2 root 2 is our answer to letter D. And that's pretty much what you're going to be looking at with the Pythagorean theorem. Like I said, should be some review, hopefully, from middle school. We're going to make it a little bit more complicated here. We're going to throw in some kind of weird expressions and maybe some problems where there's 2 unknowns. But other than that, it's just the same. It's a squared plus b squared equals c squared, like you've done before. So good luck with this concept, and I hope to see you for the next video.